Hello, today we have problem from Rodin's Principles of Mathematical Analysis. If anyone is tired of integral related problems, and the next chapter is going to be in like 2 videos or so. So what we have here is we have to show that Riemann data function is going to be equal to this improper integral. And we're given a hint that, well, go ahead and integrate over from 1 to n. I mean, it's fairly obvious, but sure. Thanks for the hint anyways, Rodin. So what we can do is we can separate this integral into a sum of integrals. We can take the starting point as n equals 1, and we're gonna sum to n minus 1. In the integral bounds are gonna be from n to n plus 1. Now we were to look into the integrate expression, and we were to look into the partition of this integral, then only the last segment is gonna include the supremum of this function as n plus 1. So as we take refinements of this, this length is gonna approach 0, so the sum between this, the difference between the supremum and infimum is gonna also approach 0. So in other words, this doesn't matter, the fact that it can take n plus 1 as the value, and we can just swap it for n. And in the denominator we have x to the power of s plus 1. We have dx here. Alright, and I also lost s here, sorry. Now if we were to integrate this, then we get a difference n over x to the power of s times minus s. Okay, and you have a difference n plus 1 here and here. Now what we can do is we can bring out the minus s here, and we get sum. Let's bring on the n. We have 1 over n plus 1 to the power of s minus 1 over n to the power of s. Alright, now let's split the sum into two different sums. One sum with these terms, and one sum with these terms. One over n to the power of s minus 1. Alright. Now if we were to separate this sum through the means of, first of all, what we're gonna do is we're gonna replace the bounds here to get a nicer fraction. We have n is equal to 2 up to n. What we get here is n minus 1 over n to the power of s. Now we can split this again. And also we can replace n here for 1 due to the fact that the first sum will be just 0, so it doesn't matter. So let's go ahead and split this. N is going to be 1 over n to the power of s minus 1 minus the sum of n equals 1 up to n capital of 1 over n to the power of s, and then we subtract this. Alright, now I'm gonna go ahead and check everything just to make sure I didn't fuck up horribly anyway. because I do sound like the type of person to do that. I often do mistakes in the videos, unless you haven't figured out that, then I totally don't do any mistakes in the videos. Alright, seems fine, eh? Hopefully. So, finding the difference of this sum, so it's gonna be the n term, so 1 over n to the power of s minus 1 minus this sum, and we evaluated this integral, but it seems fishy. I mean, it feels right. I mean, no, it feels like it doesn't feel right. All right. I'm gonna get time having too many repetitions because this over here is the negative of the Riemann data function. That will imply that this integral converges to minus data function. So let's look into where we could have made a mistake here. Okay, I can see where I did the mistake. I forgot to bring out the minus while I was canceling out the s's, so in other words, let's just write down times minus, times minus, times minus, 1, 1, 1, times minus 1, and what we're getting is Riemann partial sum of Riemann data function up to n capital of s minus 1 over n s minus 1. If we're to take the limit as n approaches infinity, we get Riemann data function of s minus the limit of this thing. Now recall how s is going to be greater than 1. This implies that that s minus 1 is greater than 0. And this should imply that minus s minus 1 is going to be less than 0, so alright, I'm being silly, I think. Okay, yeah, I see. This thing is going to converge to 0, so we get just Riemann data function of s. Alright. Now this part is fairly easy to show, in my opinion, due to the fact that we have already found this integral on the practical basis. We can again write this all out as a limit next to the definition of improper integral. Let's swap this bound for, I don't know, a. Now, this integral could be expressed as a difference of two integrals, and one of them is going to be Riemann data function. So we have s over s minus 1. Minus times minus here is going to be plus Riemann data function up to a of s minus s times the integral from 1 to a of x over x to the power of s plus 1 is going to be 1 over x to the power of s dx. Alright. Now what we have to show is that these two terms cancel out when we approach infinity on a. So I have s minus 1 minus s. Alright, minus s. Let's evaluate the integral here. It's going to be 1 over x to the power of s minus 1 times s minus 1 in denominator minus... Okay, yeah, I should... I always forget to plaster the bounds here. A and minus 1 over s minus 1. Alright. Should be right, I think. Oh, yeah, no. Times -1, so plus here, because it's not just s minus 1, it's minus s minus 1. Alright, now what we have here is to multiply this 2, then this cancel out, and the only thing that we have left is s over s minus 1 times alpha to the power of s minus 1 times -1, so minus s minus 1, alright, and as a approaches infinity, this thing over here is gonna approach 0, so we get is just 0. Alright, I didn't write down the limits here because it would take too much time to write it down with mouse, but you get the general point and you would probably be able to follow me through here. So I hope you liked the video. That's it for today. Bye, yeah.